Hello, welcome to Introduction to Java Programming. In this session, we will discuss about anonymous inner classes as part of the local classes. Let's begin. We have seen inner classes are three kinds. One is the member class, and other two are local classes. And a local class which is named, and a local class which is unnamed, that is nothing but anonymous inner class. So let's understand these local and anonymous classes here. What is a local class? Local class is a class that is created inside a method. Any class that is created inside a method is actually a local class. And the local class cannot have static members. Of course, local is an inner class, and any inner class cannot have the static members. But final static fields are allowed, because final static means constants. Any final variable by default will become like final static. So that is allowed. And any local class cannot have accessibility modifiers or access modifiers like private, public, protected, and default, because they are local. So you cannot actually say access modifiers to the local things. Okay, so just to understand the local class, let's actually write a simple code actually here. Yeah, so now I have a public class outer. Let's assume I have some data member, that is data. Now I'm going to write some method. So I will keep my method name as a public void disp some method. So as part of this method, now I am going to define a class that is a local class. A class that is defined inside a method is a local class. So now I'm writing here. So class local, my class name is local. And this class has, let's say, a method. That method name is message, just like the previous example. And here, this particular message method is going to access this particular data item from the outer class. Okay, so this is data from outer class. So this is what actually being accessed. Okay, so now this is the local class. A class which is defined inside a method actually. So in the disp method, I have the local class. So local class definition is here. So this is a class N. Now inside the method itself, because I have a local class, right? So now I have to instantiate it. So local L equal to a new local. I'm instantiating this. And yeah, so I need to call that particular method. So L dot message, my local class message method is going to get called. Okay, so now in order to get this behavior, what I need, I require an object actually. So object of which class? Outer class. So let's create the outer class object. So outer out equal to a new outer. Yeah, so now I need not to create a local class object here, because already it is instantiated in the method itself. Just I need to call that particular method. So out dot disp. When I say out dot disp, as part of that, what happens? Local class definition was there. It got instantiated, and the message method is called. Now we should able to see the output as data from the outer class. So that's it. So this is about the outer class. Sorry, this is about the local class. A local class defined inside outer class. So let me compile and show you that here. So Java C outer.java is compiled successfully. And when I say Java outer, now you can see the output coming like data from outer class, that is 99. Fine. So this is about the local class. Local class is simple. Okay. Yeah. So now let's actually go ahead and understand the anonymous inner class. This is very, very important to understand, and it has so many uses actually. So anonymous inner class is an inner class. That means it is non-static, and which has no name. Okay, it's an inner class which is a local class and which has no name. Now, how to identify that? How to identify that? Okay. So because it has no name, what we do is we straight away create an object of it. So this is the class definition. This is the class definition. And we straight away create an object of it. Okay. And that object being referred by, it's a super type. So we know super classes can refer to their child class object, right? So now whenever you write anonymous inner class, that's always going to be the child class. Okay. And we are going to create an object of it, and which is being referred by the parent. So anonymous inner class combines the process of definition and instantiation. So let me explain that. It combines the process of definition and instantiation. So now what happens? What is the process of definition? A class is defined like this. Fine. So this is the class definition. This is the class definition. And it will have a name, but we don't have a name. Now what happens is this class is going to get instantiated. So new. So in order to instantiate it, okay, we don't have a name. So what we do, we actually instantiate it with its parent type. So new, so its super type we will take, whatever it is actually. If I write one example, you will understand straight away. So new followed by the parenthesis, and here we are not putting the semicolon. New super type of what? This object. So now an object is going to get created, and this can actually be referred by the super type, whatever the super type I'm using. That means the parent type, whatever I'm using, super type some s equal to a new super type of this particular class definition, and followed by semicolon actually. Okay, so now what is going to happen? Let me actually tell you here. We have an anonymous class. We have an anonymous class. It is going to get instantiated. So now I will have my object. This is the object, and which is being defined by, which is of the super type, which is of the super type. So this S is going to refer to this object. This is the anonymous inner class object. It has no name, but object is getting created with the new operator, and which can be referred by its super type, right? So S is of its super type. For example, it's the child class, it will have some parent class, right? So that is actually going to be over here. Okay, so that's how anonymous class is going to get defined and going to get instantiated. Okay, so anonymous inner class combines the process of instantiation. Process of instantiation. Okay, so this is process of instantiation plus class definition. So here, whatever you want to define, that can be defined over here, and finally end with a semicolon. So this is how anonymous inner class will be there. Now let's go back here, and this is the syntax. So this is a process of instantiation. So new followed by super type. Optionally, you can have arguments or without arguments, and here this is the class definition, and this is the semicolon. And usually anonymous classes are created within abstract classes, within interfaces, and within classes. Okay, so classes, it is actually not much relevance, but for abstract classes and interfaces, it's more relevant. The reason is an abstract class has to be extended by some class. So there should be a child class. Now the child class can be anonymous inner class. Now interface has to be implemented by some class, and that class can be now the anonymous inner class. So usually anonymous classes will be part of the abstract classes and interfaces. And these anonymous classes will implement those abstract methods of abstract class and interface. That's how it is designed. And if you see the Java API, you can actually find so many anonymous inner classes implementing the abstract methods of the interfaces. Okay, of course, an anonymous inner class can override the methods of a class also. Within a class, you can actually define an anonymous inner class, and that is actually overriding the methods of the parent. Okay, let's now see an example so that it is easy to understand. So I'm going to write a class over here. I'm going to write a new class here. So let us assume I have a class person. My class is public class person, and this class, let me say, yeah, so this is person.java. Okay, so what I'm going to do is, so this class has an abstract method, abstract void eat. What a person will do, person will eat, right? So what he will eat, we will define actually. So this is my abstract class, right? So since it has an abstract method, I have to make my class as abstract. So this is my public abstract class person, and I have an abstract method. And because it's an abstract class, it may have some normal methods also. Let's say public void speak. Okay, so public void speak, and this is my concrete class, and person speaks, let us assume English. Okay, so this is my concrete class and this is my abstract class, and percentage of abstraction is 50%. So this is my person class, right? So here, can I create can I create object of the person? No, right? I cannot create object of the person class because it's an abstract class. Now what I do is, now I define an anonymous inner class. I define an anonymous inner class, and that anonymous inner class is going to implement this eat method. If wish, the anonymous class inner class can override this method also. Okay, so now how I can do that is, so I can have my test class here. Okay, let us assume I have my test class. So this is my person class. Let me compile and save this. Yeah, so let me say Java C person.java. It's taking time to compile. Java C person.java, we have an abstract method, and we have, of course, a concrete method as well, and successfully compiled. Okay, so if you want to see the bytecodes, we can also see that. Yeah, so compiled from person.java, and I have one constructor and one abstract method and one concrete method. So that's all fine actually. So now what I want to do is, this is my test class actually. So here, from my test class, I would like to uh, I would like to, so what actually we have to do, when you have abstract class, there should exist another class that extend this person class and provide the implementation, right? So usually there should be a class, public class test extends person, and then provides the implementation for that. Now what I'm doing here is, in this particular class, public static void main, this is my method, right? This is my method. So here I am doing something like this: person p equal to new person. Can I create an object like this? No, because person is abstract class, it's a compile time error. I'm not creating, but what I'm doing is, actually the first line is process of instantiation. So this is process of instantiation, plus I'm going to have class definition. So now I'm going to write my anonymous inner class within this particular uh, main method. So inner classes, anonymous inner class is a local class that should be within a method, right? So now what I'm doing, I'm going to implement this method. So void eat method is there, right? So this method I'm going to implement here. So void eat, and we have to provide certain implementation. I'm saying here, eating fruits. Eating fruits. That's just the implementation. So in my anonymous inner class, I have a method. So this is actually providing implementation for my parent class abstract method, and it's done. So this is the class definition. From here to here, it's the class definition and providing the implementation. And so this class, actually what it is doing internally, it is extending my person class. Okay, it's extending my person class, providing the implementation of the eat method. My person class is an abstract class, and an object is getting created, which is referred by person type. because the class which I have defined is subclass of my person class, which is an abstract class. And abstract class has an abstract method, it is implementing it. And object is getting created, and that is referred by P. So now I can say P dot eat later. Okay, that's it. Okay, so who is implementing this person? Who is extending and implementing this person class? And there exists a class that is anonymous inner class that is implementing the eat method, and the object of this class is getting created and referred by parent, because the parent is person here for this particular anonymous inner class. That's why I'm implementing this eat method, and I'm done actually here. Now let me actually compile this test class Java C test.java. So Java C test.java test class has actually uh, anonymous inner class inside. Yeah, it's compiled actually. Now when I run actually Java space test, now it's actually saying eating fruits. So this eat method is of my parent class method. So now for example, if you say ls, now you can see the test.class files here. Somewhere you can actually track down here. So you have test.java, test.class, and you can also see test$1.class. This test$1, in the test class, you have anonymous inner class that is actually test$1.class. Okay, fine. So this is how anonymous inner classes can actually be used to implement the abstract methods of abstract classes and interfaces. Now let me actually uh, show you something actually here. So this main method, whatever I have written, right? So I'm not now writing in the main class. I'm taking that to my person class itself. I'm taking that to my person class itself. So my class public abstract class person, and I have one abstract method and one concrete method and a main method now, and a main method. So here in the main method, now I am going to have another class. This is the anonymous inner class. Now this anonymous inner class is going to be person$1. This is going to be person$1. So this is actually implementing the seed method. If required, it can actually override this particular speak method also. Public void, we can override this also. Public void speak, because however anonymous inner class is extending the person class, it can override also. Right. So now let's see public void speak, and here how it overrides. So they are saying English, right? So now we say here speaks Hindi, speaks Hindi. Okay, so now p dot eat, and I'm also saying p dot speak. So my anonymous inner class is actually providing the implementation of the abstract method and providing the overriding my speak method. Override speak method is a concrete method that is getting overridden over here. So now I can compile my person class directly, and I can run the things here. Java C person.java. Now my person class is going to have one anonymous inner class also. Okay, so if you want to see, say ls here, go to the person. Now you can see person$1, because this person class is actually having now anonymous inner class as part of the main method. Okay, so now let me run Java person. Then it's going to be, yeah, eating fruits and speaks Hindi. Okay, so this is how we told actually anonymous classes can be created by abstract classes and interfaces, right? And here in this example, what we did, an anonymous inner class created as part of my abstract class person, as part of my method main actually, right? So this is one example, and we can actually do this with interfaces also. You can do the same with the interfaces also, right? If at all I have to do with interface, what I need to do is I just make this one actually uh, as an interface, and I will have the same code actually. So what I do is I will actually keep another name for this file Yeah, I will actually keep person, interface person. I say I person. Okay, so now here what I do is, it's not a class. What I'm doing, public interface. Public interface I person. And you know, interface will have all the abstract methods. All the abstract methods. I will keep all these things as abstract. Yeah, void it and void speak. So this is my interface, public interface, I person, interface person, void it and void speaks, right? Okay, now I have my main method also. I have my main method also here in the interface. I have my main method also in the interface. Yeah, so let me save this as I person. I person.java. So now my interface is going to have two abstract methods. And in the main method, what I'm doing, I person. So interfaces can refer to their implementation classes. So now the implementation class is going to be, anonymous inner class. Okay, so now because it's interface, all the members are public. So public void eat, this is one implementation, and public void speak, this is other implementation. And finally, my class is done. So this is actually my anonymous inner class inside an interface. Okay, and inside of a method, so it's a local class. And what it is doing, it is providing implementation for the abstract methods of the interface. That's the main purpose actually. In Java API, you can see so many interfaces which are actually having methods getting implemented using anonymous inner classes. So here I have the anonymous inner class which is defined, and what it is doing, it is implementing the abstract methods of this I person. And this is getting instantiated because in the definition it has instantiation, and it is instantiated and referred using a super type, that is your interface. Interfaces can refer to their implementation classes, and that is P, and later I am saying P dot eat and P dot speak. Later on, whenever we discuss multi-threading, we will create so many threads using anonymous inner class concept actually. So now let me compile this iperson.java, Java C iperson.java. Now also you can see this iperson.class as well as iperson$1, because it's having an anonymous inner class as well in it. So now let's see ls. If you say ls, so go to I here, you can actually see iperson.class and iperson$1. So this iperson$1 is anonymous inner class that is implementing the interface iperson and providing implementation for these two methods. Okay, let me actually run this. So Java C iperson, because iperson has the main method, and main method has this particular anonymous inner class. So Java P iperson, then I'm going to see the output eating fruits and speaking Hindi, speaks Hindi, right? So we are actually getting right. So now you see interface is having a main method, abstract class is having a main method, but as part of that main method you have anonymous inner class. So now what we can say, abstract classes can have nested classes, that is anonymous inner class. Interface can have nested types, anonymous inner classes. Not just abstract methods and constants, it can also have nested types as part of the methods. Abstract class can have data members, constructors, methods. Along with that, it can also have nested types. It can also have nested types. Those are nothing but anonymous inner classes. In the same fashion, it can be class also. So I'm saying it is abstract class here, right? Now I can just make public class person, and this method also can have some behavior, and my anonymous inner class can override it, right? So that's what we are telling you over here. Anonymous classes can be created by either a class. Inside a class, you can have anonymous classes which override the methods, and abstract classes definitely require anonymous inner class, because abstract classes has to be extended by some other class. So here comes the anonymous inner class. And interfaces also require anonymous inner class because interface have to be implemented by somebody else. That somebody else is going to be anonymous inner class. So that's about the anonymous inner class, and hope you have understood. So anonymous inner class is an inner class basically, and it's a local class. It is always defined inside a method and which has a no name. So how to identify this? So it combines the process of instantiation plus class definition, and whenever the class is defined, it will get instantiated, and its object is being referred by its super type. That may be a class, that may be an abstract class, that may be an interface. And most of the times abstract classes and anonymous interfaces will use anonymous inner classes. So hope you have understood, and that's about the nested classes. And so meet you with other session, maybe packages. Thank you.